Good afternoon, Coryell's class.
Good afternoon, Mr. Pottinger.
Today we finished the area model of multiplying fractions. Can you multiply fractions?
Yes.
All right. Factor. A factor must be what or what according to the given number in order to be a factor. It must be what or what?
Smaller or equal to.
A factor must also go blank into a number to be considered a factor. It must go what? Nicely, easily, evenly, however you want to word that, okay? So factors are going to be smaller or equal, and they have to go nicely into the given number. All right, area model. We're going to use this one. Step 1, area model. We're multiplying 3/4 times 2/3, right? If I multiply straight across, I get 6/12, but we're not. We're actually showing it using the area model down here, yes?
Yes.
Step 1 is to create a candy bar. So in order to multiply or show the area model with 3/4 and 2/3, we have to create a candy bar, right?
Yes.
Step 2 is we have to label the top and the side with our fractions, right?
Yes.
Which fraction goes on the top?
3/4.
The first one, right?
Yes.
Second one goes on the...
Side.
So think of this. Second fraction side. Second side. S and S, right? All right, so now I have 3/4 on top. I need to split my candy bar into how many parts?
4.
So 1, 2, 3 lines gives me 1, 2, 3, 4 parts, yes?
Yes.
I need to split the candy bar going in the opposite direction into how many parts?
3.
So if I do 2 lines like this, I've got 1, 2, and 3 parts, yes?
Yes.
How many different pieces now exist? How many pieces exist?
12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right?
Yes.
What is the product of our denominators?
12.
So the product of our denominators tells us how many pieces this candy bar should be split into, right?
Yes.
Now, I need to show 3/4. I'm going to use the letter T because T stands for what?
Top.
So if I use the letter T like this, it's showing that 3/4 of my candy bar is shaded in, right?
Yes.
I also need to show 2/3 going across, yes?
Yes.
What letter should I use? So if I go S going across like this and S going across like this, isn't this 1 2/3?
Yes.
Now to figure out how many are shaded in, we have to look for the T and the S. How many T's and S's are completely shaded in?
6.
And that's our numerator, right?
Yes.
So 6 of the 12 are shaded in, which is our answer. 6/12, yes? Okay, and then obviously we reduce that down. We have 2 problems here, number 8 and number 9, but it's the same problem, yes?
Yes.
If you multiply without reducing, you're going to deal with some pretty big numbers. True or false?
True.
We ended up getting 3/8 as our final answer. In number 9, notice 6/8 times 7/14, 6/8 times 7/14. What do we do first here? We reduce, so 6/8 can reduce to what? 7/14 can reduce to what? Are these numbers easier to deal with than these numbers?
Yes.
So in the end, we think it's easier to reduce first or multiply first. Which one? Reduce first because you're going to be dealing with an easier math problem, yes or no?
Yes.